Okay, everyone, assalamu alaikum. I hope you guys are all well. So, we are starting some topical past papers for IGCSE and O levels. I'll be doing some live streams over the next couple of weeks in which we will be doing difficult questions from recent past papers of different O level and IGCSE math topics. We are starting with trigonometry today, and then we will do a few other topics over the next 1 or 2 weeks, inshallah. Okay, we also have a yearly past paper session starting in the second week of March. In fact, towards the end of the first week of March, 6th or 7th April. The link for that is there in the comments and in the chat on the side. You can have a look at that. It's there in the description of this video as well. If you want to register for yearly past paper sessions, we have two separate sessions for IGCSE and O-level maths. You can have a look at that as well. So let's start with this. We're starting with some questions on trigonometry today. Let's have a look at the first one now. So these are taken from some recent papers. I've had a look at the different questions that have come in the last 3-4 years, and I've chosen the ones that are relatively more complicated. So let's start with this one. So it says the diagram shows the positions of 3 towns A, B, and C. B is on a bearing of 72 degrees from A. What does that mean? B is on a bearing of 72 degrees from A. So the angle is going to be at the point A. What's that angle? This angle is 72 degrees. This angle is 72 degrees. That's what we're given. And C is on a bearing of 150 degrees from A. So C is on a bearing of 150 degrees. That means this whole angle, that is going to be 150 degrees. AB is 300 kilometers and AC is 280 kilometers. All of that is given in the diagram already. We need to find the bearing of A from C. So bearing of A from C. So from C means the north has to be at the point C. So this is where north is going to be. We want to find the bearing of A from this point. That means we're looking for this angle. Okay, that's what we are looking for. So let's see how we can find this angle now. What do we know about this diagram? So we know that this angle is 150 degrees. You see, it's a 1-mark question only. So it should not involve a lot of calculation. We can see on the diagram, this angle is 150 degrees. Now, what does that tell us about this remaining angle? If I were to extend this line below, this remaining angle would be 30 degrees. 180 minus 150, that's 30 degrees. If that angle is 30 degrees, this angle here is an alternate angle, right? So both are vertical lines, this 30 and this 30. They're alternate angles, so this angle is 30. What's the bearing of A from C then? Bearing of A from C, that's this angle, 360 minus 30. This angle turns out to be 330 degrees. That's the bearing of A from C. That's what we were looking for in the first part. Okay, so that's 330 degrees. Now let's look at the second one. Now it says, calculate the length BC. Okay, calculate the length BC. So now we're looking for this length. Now, what information do we have about this triangle? We know two sides. We have 300, we have 280 here. We know two sides of this triangle. And we know that this angle is 150 and this angle is 72. What we can do that using those two angles is we can figure out this angle in the triangle, right? So basically, this complete angle is 150. If we subtract 72 from that, if we subtract from 150, 72, we can get this angle. All right, so let's do that. 150 minus 72, that gives us 78 degrees. So this angle is 78 degrees. So now we have two sides and the included angle, the angle between them, and we're looking for the third side. We want to find the length BC. Now we can't use sine rule here because we don't have any pair of angles and sides. So we don't know what the angle opposite to 280 is. We do not know what the angle opposite to 300 is. We only know this part, but we don't know what the other part is. All right. So what do we do then? We can't use sine rule. We have two sides and the angle between them. This is a case that, and this is the case in which we use cosine rule. All right. So let's use cosine rule on this and see what the length BC turns out to be. So let's try this. The length BC. We have two sides and the angle between them. What's the cosine rule? This is what the cosine rule looks like. A squared equals b squared plus c squared minus 2bc cos of A. Now the angle that you have, A is going to be the side opposite to that angle. So this is supposed to be A. All right. And that's what we're looking for. So we can say BC squared, that equals one of the other side squared. So you can use any of the two other sides. Let's say 300 squared plus 280 squared minus 2 into B, which is 300 into 280 into cos of this angle, which is 78 degrees. And that should give you the result. You can see what BC turns out to be. You can first write that. Just change my calculator unit. Degrees. Okay. So 300 squared plus 180 plus 280 squared minus 2 into 300 into 280 into cos of 78 degrees. And that's giving us 133,000. Can't be that big. I'm sorry. Yeah, so that's okay because we haven't taken square root yet. So this is BC squared. BC squared equals 133,471. Or actually, I write the more accurate number, 70.84. Now we take square root as both sides. BC turns out to be 365.34. That's the length of BC. You can write it like this, or if you want, you can round it off to 3 significant figures. In that case, it would become 365, and that's also fine. You can also leave it like this. This is also going to be acceptable. Okay, let's have a look at the next one. Now it says town D is 145 kilometers from town D. Okay, so town D. So there's some town D. We don't know where that is. We only had A, B, and C shown here. We don't have D shown on the diagram. Now this town is 145 kilometers from town B. Okay, 145 kilometers from town B. Angle ADB is 120 degrees. Find the two possible bearings of D from A. You may add lines to this sketch to help you. So they've given us another sketch and they're saying the sketch might help you do this calculation. Okay, so we have the angle ADB given to be 120 degrees and they're looking for two possible bearings. Now, let's think about this. Angle ADB. So the angle at the point D, angle at this point D, that angle is supposed to be 120 degrees. Now, where can that point D be? Now, it could either be above this line or below this line. So the angle D could be 120 with something like this. Now this is more like 90. So let's make this angle slightly bigger. So maybe it's like this. So one possibility could be that D is maybe above this line, such that this angle becomes 120 degrees. Now, of course, it's not to scale, so the angle does not have to be very accurate. So this could be one possible position of D. Another possible position of D could be below this line. Let's say that's here. That could be another possibility. It could be one of these two possible cases. What we want to find is the bearing of D from A. So north has to be at the point A. We are either looking for this angle or this angle. So we just want, we basically want both of these angles, okay? Now, how can we find these angles? Let's consider both cases one by one. Let's consider the first case, the one on top first of all. Let's consider that first of all. Let me just use a different color for this one so we can differentiate between the two. So I'm talking about the blue case right now. So if this angle is 120 degrees, how can we find this bearing? Let's think about this. So what information do we already have? We know the bearing of B already. What was that? That was 72 degrees. That is something that we already know. This bearing was 72 degrees. So this complete angle is 72. Okay, so that's one piece of information that we have. We also know the length of BD. So D is 145 kilometers from D. So if D was here, it would be 145. D was here. This would also be 145. Now, in fact, let's actually not write 72 here for now. We'll write it later, just to reduce a bit of clutter. What we can do is we can basically find this angle. Let's call this angle theta. How can you find this angle? We have this side, and we want this angle opposite to that side. And we have this side, and we know the angle opposite to this side already. So we have one pair given, and the other pair, we have one missing piece of information. In the upper triangle, what we can do is we can say, let's use sine rule. What does that give us? We could say sine of theta divided by 145. That can be equal to sine of 120 divided by 300. And that's going to give us a value for theta, all right? 145 into sine of 120 divided by 300. So that will give you some value. I'm actually show working for this. So this is giving me sine theta equal to 0.4185. And that gives us theta equal to, if we do sine inverse of that, theta turns out to be 24.744 degrees. That's the value of theta that we get. Now, the lower triangle has the same length. This is 145. This is 300. This is 120. So that means this lower angle, this would also turn out to be the same. This is also going to be theta. So both of these angles are 24.74. Now, we were looking for two possible bearings of D from A. So what are the two possible bearings? Now comes in this angle that we were already given. We were given that the bearing of B from A is 72 degrees. So we know this complete angle is 72 degrees. Okay. So if we want bearing of D from A, bearing of this D from A, what would that be? This bearing, we could subtract from 72 this angle theta. So from 72, if we subtract theta, we're going to be left with this angle that we're looking for. That's going to be the first bearing. Bearing of D from A, one possible value could be 72 degrees minus 24.74. What does that give us? 72 minus this. That's 47.25. That's 47.3. Now, since you're talking about bearings here, we should write it like this: 047.3 degrees. That is one possible bearing. That's one possible bearing. Now, similarly, we could write the other possible bearing as well. The other one could be if we add to 72 this theta, and that will be this complete bearing. That will be this complete bearing. So this is 72, add theta to it, and that's going to give you the second possible value of bearing. What's that? That's 72 degrees plus 24.74. What does that turn out to be? 72 plus 24.74. That's 96.74. Again, since you're talking about bearings, we should write it as 096.74. Or you can say just 7 because values in decimals, we generally write them correct to 1 decimal place. These are the two possible bearings that we're getting, 47.3 degrees or 96.7 degrees. All right, and that's our final list. Okay, now let's have a look at the next one. So now we have this horizontal ground ABCD. So it says ABCD is a field on horizontal ground. The bearing of B from A is 70 degrees. The bearing of D from A is 125 degrees. Let's actually mark that on the diagram. Bearing of B from A, so this is point B, from A, what's that going to be? 70 degrees, that means this angle is 70. Bearing of D from A, that means this angle, this is 125 degrees. Now C is due south of B. C is due south of B. You can see that. So that means this is horizontal, this line. And due east of D. Okay, sorry. It's due south of B. So this is a vertical line. And C is due east of D. This is a horizontal line. We have the two lengths given, AD and BD. We can see that on the diagram as well. In the first part, it says, calculate the bearing of D from B. Okay, so D from B, where is the 90 degrees? Where is the north going to be? The north is going to be at the point B. We're looking for this bearing. Okay, that's what we want. Now, if you think about it, this angle is 180. So the only problem is we want to find out this angle. Once we have this angle, we can just add 180 to that, and that will give us this bearing. Okay. Now, how can we find this particular angle? Let's think about this. We could think of using this right angle triangle, but the problem is we don't have enough information in this triangle. This is 350. The hypotenuse is 350, but there's no other information given. In this triangle, there's no other information. We don't have this side. We don't have this side. So that's not going to be helpful. However, what we're given is that this angle is 70 degrees. Now, if this angle is 70 degrees, that means this is also 70. This is an alternate angle, right? This angle is also going to be 70. If we can somehow find this angle in this triangle, we can subtract that angle from 70, and that will give us this remaining angle. Okay, so that's what we can do here. We can say, let's figure out this angle first in this bigger triangle, and then we will subtract that angle from 70 to get this remaining one. Okay, now let's call this angle something. Let's call this theta. Let's say we're looking for this. How can we find this angle? Well, we know that this is a pair that we have, 290 and theta. That's one pair. Theta is what we have to find out. 350 length is given. What about the angle opposite to 350? Now we are given two bearings. We are given that this is 70, this is 125. So 125 minus 70 is going to give us this bearing. All right. Let's figure this out. 125 minus 70, what does that give you? 55 degrees. So this angle, therefore, is 55 degrees. Now we can use sine rule to find the value of theta. Let's see what that turns out to be. Sine theta over 290, that should equal sine of 55 over 350. And that's going to give you a value for sine theta. Let's see what that turns out to be. 190 into sine of 55 divided by 350, and that's giving me 0.6787. Let's do sine inverse of that. The angle theta turns out to be 42.74 degrees. That's the value of this angle theta. Now, what about the remaining angle? Let's call this theta 1. This is the value that we have for theta 1. Let's call the other angle, the remaining angle theta 2. What's the value of that going to be? Theta 2 is going to be 70 degrees minus 42.74. Why? Because this angle is 70. If this is 70, this angle is an alternate angle. So this complete angle is 70. We have one part of this 70, that is 42.74. How can we find the remaining part? By just subtracting 42.74 from 70. Let's see what that gives us. This is 27.26 degrees. So now once we have this angle, we were looking for bearing of D from B That means we were looking for this complete angle. Now we can have that 180 is the angle of the straight line. Add to that theta2 and you'll get that bearing. So what's the bearing that you're looking for? 180 plus this small angle, which is 27.26, and that's going to give you 207.3 degrees. That's the bearing that we were looking for, 207.3 degrees. Okay, that's what we get from this. Okay, now it says a vertical mast is positioned at D. Okay, so now it's something related to 3D figures. We have a vertical mast that is positioned at this point D. So at this point D, we have a vertical mast. So it's like a vertical tower or something, right? So the vertical tower or something, right? So that's what we have here. The angle of elevation of the top of the mast from A is 10 degrees. Now, how do you think about that? So at the point D, we have a vertical line coming out of this plane, out of the page, right? It'll be a 3D diagram. So at D, we have a vertical line coming out of the plane. So we could think of it like this. Let's say the top of the mast, we name it something. Let's call this T. So we could think of a diagram like this. It's often helpful to draw right angle triangles when you have 3D trigonometry like this, that D is the point on the ground. This is the top of the mast. So in that diagram, I could perhaps draw T like this, let's say, but this line is actually coming out of the screen. You have to understand that. Then this line has to come out of the screen. I could draw it like on this side, let's say this is T, this is coming out of the screen, okay? If you were to draw it on the side here, it would look something like this. Since the angle is 10 degrees, I'm just going to make it slightly more slanted like this. This angle is 10 degrees. Okay. This angle is 10 degrees. Okay. Okay. This angle is 10 degrees. All right. We need to find the angle of elevation of the top of the mast from C. Now, if you were to draw a line from A to the top of the mast, remember this is coming out of the screen. This angle we are given is 10 degrees. So remember, at the point where you have something vertical standing, at that point, all the angles are 90 degrees. So if I were to make an angle at this point D with A, this angle would be 90. Angle with C would also be 90. Angle with B would also be 90. All of these angles are going to be 90 degrees, right? Because DT is supposed to be a vertical line. So for that reason, I could also draw another triangle like this, DTC. Since we're looking for the angle of elevation from C, we can also draw another triangle like this. This would also be a right angle triangle because all the angles at the point D are going to be 90 degrees. Okay. So I could draw another triangle like this. It will look something like this with C. D is at the bottom. And you have a right angle at this point D again. T is at on top. And this point is C. We are basically looking for this particular angle. All right. Now, since the mast is vertical, the angles at the point D are both 90. Okay. Angle TD with anything else is going to be 90 degrees. Now we need to find this angle theta somehow. What information do we have? We are given that this angle is 10 degrees. Now, do we have any of these lengths? If this was B, right? No, sorry, A. Do we have any of these lengths? Do we know AD? Let's go back to that diagram and see if we have AD given. We know what AD is. AD is 290. So we can write 290 here. That's AD. So we have a right angle triangle in which we have one side given and we have an angle given. What we can do is we can use this information to find this length dt. Why? Because that is common between these two triangles. If we can find the length dt, we can use that value here in the other triangle, because in that other triangle as well, we already know the length CD, do we? We don't. Let me actually think about it. CD length is not known, but we could find that. Let's actually come back to that in a moment. This is the information that we have. Let's find dt first of all. Let's use this information to find the length dt and see what that gives us. So what ratio can we use? This is perpendicular. This is base. Base and perpendicular, what's the ratio? Tan. Tan of 10 degrees is dt over 290. And that's going to give you the length dt. 290 into tan of 10 degrees, what does that give us? That gives us 51.13. Okay, so we have the length dt now. This length is 51.13. Now, can we find the angle theta yet? Well, we can't yet. We need some other information as well. We need the length CD somehow, right? Because that was the length that was already given on that diagram, as in it was there. It was part of that diagram already. Can we find the length CD on this diagram somehow? In this 2D diagram, CD, this is the side CD. Now, let's think about this. This angle is 350. This angle theta 2, we have already found. It's 27.26 degrees now. So from this triangle, we can figure out the length CD as well. Now, again, let me draw that triangle below there. So we could have this in front of us. I'll take this a bit down. We'll come to this in a moment. The other length that we're looking for is the length CD, right? Was it like this? No. Now I'm just drawing these triangles to help you understand this. You don't necessarily have to draw all of these. You could do it without this as well. This is the right angle. Here, we know the length 350. We know this angle. This is 27.26. We can find the length CD using this. What ratio do we use? This is the base. This is this is perpendicular, sorry, because the angle is this one. This is the angle. So with respect to that angle, this is perpendicular. What's the ratio between perpendicular and hypotenuse? It's sine, so we can say CD over 350. That equals sine of 27.26 degrees. And that's going to give us the length of CD. Let's see what that turns out to be. 350 into sine of 27.26. That's 160.31. That's the length of CD. All right. Once we found the length of CD, now what we can do is we can use that length here, 160.31, and we can use this length now to find that angle theta, the angle of elevation that we were looking for. We could say in this triangle, we have the perpendicular, we have the base. We could use tan theta like this. Tan theta equals perpendicular, which is 51.13, divided by the base, that's 160.31, and that's going to give you the value of theta. 51.13 divided by 160.31. tan inverse of that, and that's giving me 17.68. 17.7 degrees. That's the length that we get for this. All right. And that's the angle that we get for this, the angle of elevation that we were looking for. The angle of elevation is 17.7 degrees. Okay. All right, let's move on. Next one. So we have now this, again, another 3D diagram. The diagram shows a cuboid. TW is 15 centimeters and WV is 10 centimeters. RV is 8 centimeters. You can see all of that information on the diagram already. Show that TR equals 19.7, correct to 1 decimal place. Now, what's TR? Let's look at the diagram and see what TR is. TR is this length here. Okay. Now, how can you find the length of TR? What right angle triangle can we use? We could make a right angle triangle like this, RVT. Right? Now, since RV is vertical, that means we're going to have a 90 degrees here. This angle is going to be a 90 degrees. Now, what information do we have about this right angle triangle? Well, we only know this length 8. In order to find TR, we would need some other information as well, maybe another angle, maybe another side. In this case, we only have one side given. So what can we do then? We can first use this triangle, PVW. This is also a right angle triangle. Remember, it's a cuboid. The base is a rectangle. So this is going to be a right angle triangle. Let's consider this one, triangle TWV. This angle is a right angle. We have two sides for this already, 15 and 10. We can find TV. We can say TV squared is equal to 15 squared plus 10 squared. And that's going to give us the value for TV. TV squared turns out to be 325. And then TV, if we had to calculate that, that's 325. You can just leave it like this because we have to use it further now. What about TR now? Once you know what this length is under root 325. Now you can use that right angle triangle. TR is the hypotenuse of the other right angle triangle. The other right angle triangle is TVR. So we can use that one now. In that triangle, we can say TR squared. That is going to be equal to TV squared plus VR squared. TV is 325, square root of 325, we square that, and that's going to give us 325 plus VR squared, that's 8 squared. What does that give us? 325 plus 64, and then square root of that. TR turns out to be 19.72. Now to 1 decimal place, it becomes 19.7. And that's what we had to show in this part. So the length of TR is 19.7. We found that. Okay. All right, let's look at the next part now. Now it says X is the midpoint of PQ. Calculate TRX. X is the midpoint of PQ. Okay, so this length, this point is the midpoint of PQ. Calculate TRX. TRX. So we want to find this angle TRX. Let's call this theta. This is the angle that we're looking for. Okay, how do you find this angle now? Let's think about this. TRX. Okay, so if you look at the triangle TRX, what information do we have? Now, let me just erase the previous highlight. Let's focus on this triangle now. TRX, this triangle. Now, in this triangle, what do we know? We need to find this angle. Let's call this angle theta. What information do we have? We know the length TR already, that's 19.7 from the first part. That's the length TR. What about XR and XT? Do we know any of them? We don't know any of them, but can we find them? We can find them using right angle triangles. So for XRQ, we can use this triangle, this right angle triangle, and find the length of QX. Oh, sorry, not QX, XR, right? We know the other two lengths already. What's QR? QR is going to be 15 because this length is 15. That's also 15. This length is 10. What's half of that? 5. We can find XR using that, right? In that right angle triangle. What's the length XR? Let's calculate that. XR squared equals 5 squared plus 15 squared. And that's going to give us XR squared, which is 250. And XR therefore equals square root of 250. Okay. Now the other length that we need is TX. Because for finding that angle, if we have all the 3 sides of the triangle, we could then use cosine rule to find the angle theta. We have 2 sides now. We know XR as well. XR is now square root of 250. So we know this length as well now. What about the third length here? How can we find that? TX. Now for TX, we can use this right angle triangle. This is also a right angle triangle, right? We have a right angle at point P. What lengths do we have here? The vertical length is 8. It's coming from here. PX is 5. We can find length TX using Pythagoras, right? How do you find that? TX squared is going to be 5 squared plus 8 squared on that diagram. And that's going to give us TX squared. All right, TX is the hypotenuse. The 2 sides are 5 and 8 in this triangle. We can use those 2 sides in this right angle triangle to find the hypotenuse, and that's going to give us TX. Now, what's TX squared? TX squared is 25 plus 64, that's 89. And then TX equals square root of 89. So we have 3 sides of this triangle now, of the triangle TRX, or of this highlighted triangle, the yellow one. We know all 3 sides of this triangle. Now the third side is square root of 89. This is square root of 89. Okay, so we have 3 sides. We need to find this angle. What can we do? We can use cosine rule for this. What's the cosine rule? A squared equals B squared plus C squared minus 2BC cos of A. Or if you remember that form in which cos A is the subject, you can use that directly because we're looking for angle, but it doesn't matter either way. Let's input values now. So what's the side A? A is the side opposite to the angle, square root of 89. Okay, so we have square root of 89 whole squared equals B squared. The other 2 sides now, one is square root of 250, square root of 250 whole squared, plus 19.7, this one, 19.7 squared minus 2 into square root of 250 into 19.7 into cos of A. And now you can find the value of cos A from this. Let's see what we get. If I were to take these 2 terms to the left side, let's see what that gives me. 89 minus 250 minus 19.7 squared. On the left side, I'm getting minus 549.09. Okay, if I take these two terms to the left. Okay, now we have minus 2 into this into this. What does that give us? Let's evaluate this as well. 2 into square root of 250 into square root of 19 into 19.7, sorry. And that's giving me minus 622.969 cos A. And cos A turns out to be 549.09 divided by that. That's 0.8814. What's the angle at the, what's the angle A now? Angle A was basically this TRX. That's what we were looking for. The angle A in this formula turns out to be 28.18, or we can say 28.2 degrees. That is the angle that we're looking for. Okay. That's the angle that we're getting, 28.2 degrees, and that's our final result. All right, so this was May, June 21, and this was the angle that we're looking for. And that's it. Okay, let's have a look at the next one. Harun, is that on trigonometry? If you're still there, let me know if it's in trigonometry. I could quickly have a look at that as well. Okay, the diagram shows the positions of three farms A, B, and C on horizontal ground. Farm B is on a bearing of 125 degrees from farm A. AB is 950 meters, BC is 680 meters, and AC is 520 meters. Show that angle BAC is 44 degrees, correct to 1 decimal place. Okay, so what information do we have? We have a triangle, we have all three sides in the diagram given. We need to show that angle BAC, that is 44 degrees. Now, it's the simple application of cosine rule. So I'm going to do this very quickly. Let's call this angle theta. Let's input values in the formula. A squared equals B squared plus C squared minus 2BC cos of A. Or you could use the other form if you can remember that. That's going to be simpler in this case. You can do that. So the other form would be, you could rearrange it and write it like this: cos of A equals B squared plus C squared minus A squared divided by 2BC. All right, you could also use that. It's your choice. If you were to use that, because you're looking for angle, let's see what we get. B squared, what's the side opposite to this? 680. All right, so 680 is going to be A. B and C are the other two sides. So that means 520 squared plus 950 squared minus 680 squared whole divided by 2 into B into C. That's 520 into 950. That is cos of A. And that's going to give us some value. Let's see what that turns out to be. 520 squared plus 950 squared minus 680 squared divided by 2 and 520 and 950. That's giving me 0.7191. The value of theta from this is cos inverse of this number, which is 44.02 degrees. That's 44.0 degrees. That's what we had to show in the first part. Okay. Now it says calculate the bearing of A from C. Bearing of A from C. What does that mean? We make a knot on C from C. So the knot has to be on C. This is what we want. Now, how can you find this? We know that this angle theta is now 44.0 degrees. What does that tell us about this remaining angle? What is this going to be? 180 minus 125 minus 44.0 degrees. What's that? Calculate that. 180 minus 125 minus 44, and that's giving me 11.0 degrees. This remaining angle is 11 degrees. Now, if this angle is 11 degrees, that means this angle is also 11, alternate angles. All right. This is also 11. So what's the bearing then? 360 minus 11. All right. Let's just do that. The bearing of A from C, that's 360 minus 11 degrees, and that gives us 349.0 degrees. That's the bearing that we were looking for here. $349.0 degrees. Okay, that's the result. Okay. Let's move on. Let's move on to the next one now. Now it says farm A and farm B are joined by a straight track AB. A and B just joined by a straight track AB. Amir walks along the track from A at a constant speed of 4.6 kilometers per hour. This is the constant speed. Calculate the time it takes for Amira to walk from A to the point that is closest to farm C. Okay, it was Amira throughout, not Amir. Okay, so she walks along the track at a constant speed of 4.6 kilometers per hour. Okay, farm A and farm B. What were these points representing? Yeah, these were representing farms. Okay. Amira walks along the track at this. Calculate the time it takes for Amira to walk from A to the point that is closest to farm C. Okay. So basically what's happening is Amira is going from point A to point B. She's going this path. Now on this path, we want to find the time taken until she reaches the point that is closest to farm C. Now on this track, what's the point closest to farm C? The point closest to farm C is going to be this point that makes a perpendicular with C. Let's call this point X, let's say. This point X is going to be closest to farm C on this track because the shortest distance from a point to a line, short distance from C to this line, that is always perpendicular distance. So she is going to be closest to point C when she is at this point X, such that this point X makes a 90 degrees like this. Now we want to find the time she takes until she reaches this point. We have the speed given. If we can find the distance, we can find the time using the speed and distance after that. So all we want to find is what's the distance AX. AX is the distance that we want to find out. Now, how can you find the distance AX? We know the value of theta already. The angle is 44 degrees. We know that this angle is 44 degrees. Okay, we know this side, that's 520. It's a right angle triangle. In the right angle triangle, this is the hypotenuse. We are looking for this side. This is adjacent to the angle, that's base. So what's the ratio between adjacent and hypotenuse? It's cos, right? So we can use cos here. We can say cos of 44. Cos of 44, that should equal base, which is AX, over the hypotenuse, which is 520. And that's going to give us AX. Let's see what that turns out to be. 520 into cos of 44. And that's giving me 374.06. That's the length AX. That's the distance that she is traveling until she gets to the closest point to the farm C. Now, what's the time taken for her to do that? We have the distance, we have the speed. So we can say time equals distance over speed. Distance equals speed into time. So time equals distance over speed, right? What's the distance? 374.06 divided by the speed, which is 4.6 kilometers per hour. Now, let's actually see if the units are the same. No, so units are not the same. This is meters. So the distance was in meters, and the speed is given in kilometers per hour. Okay, now, so we have to be careful when we're doing this. So this is 374.06 meters. What's this value going to be in kilometers? It's 0.37406 kilometers. I can write that here. 0.37406 kilometers. And then in the denominator, we have kilometers per hour. So the result that we get from this, that's going to be in hours. Okay, let's see what that turns out to be. Divided by 4.6, that is giving me 0.08117 hours. Now this is time in hours. We need to convert this to minutes and seconds. Now, how do you convert hours to minutes? You can multiply this by 60. Let's multiply this by 60. What does that give us? Multiplying that by 60 gives us 4.87 minutes, 4.879 minutes. Now we want to convert it to seconds as well. So it's going to be 4 minutes into 0.879 multiplied by 60 seconds. What does that give us? 4 minutes. And this into 60, that's 52.74 seconds. Now the question says, you have to give your answer correct to the nearest second. Okay, it should be correct to the nearest second. So what do we say then? It's 4 minutes and 53 seconds. When we round off 52.74, that becomes 53. So that's the time that we're getting here. All right, 4 minutes and 53 seconds. Let's move on. Now it says a helicopter hovers vertically above farm B. The angle of elevation of the helicopter from farm A is 10.7 degrees. Calculate the angle of elevation of the helicopter from farm C. Now it's very similar to a previous question that we did. So now we have a helicopter vertically above farm B. So what's the point B? We have a helicopter right on top of B. Now this line is vertical. Let's call this H. This is vertical. So that's important. Important to remember, it's coming out of the plane, it's coming out of the screen. We know that the angle of elevation from farm A is 10.7 degrees. Now, where is the helicopter? It's right above B. So what we can do is help understanding the situation. We can draw a right angle triangle like this, because whenever we have something vertical, we could have a right angle triangle like this, with the foot of the perpendicular being this point over which you have something. So B is this point where you have a perpendicular. The top of B is the helicopter. Let's call that point H. This angle of elevation is given to be 10.7 degrees. Okay. And this point was what? A. This is given. Now, what information do we have about this triangle? Do we know the length AB? AB length is 950 meters. We know this length. We want to find the angle of elevation of the helicopter from farm C. So from C as well, we're going to have a right angle triangle here. Again, because at point B, we're going to have a right angle triangle. So we can make another one. Let's have another right angle triangle. It might look like this. Now the base of this triangle is still B, but this point is C now. Now we have C here. This is the angle that we want to find out. Do we have any information about this triangle? Let's think about this. We know the length BC, that's 680 meters. That is given already. The length BC is 680 meters. We need to find the value of theta. Now, you see HB is common between the two triangles. We can find HB from the first triangle and then use that in the second triangle to find the value of theta. In the first triangle, HB is perpendicular, 950 is the base. So we can say HB over 950, that equals tan of 10.7 degrees. What's the value of HB? 950 into tan of 10.7 degrees. And that's giving me 179.5. Now use that here. This is 179.5 now. Again, use tan here. You say tan theta should equal 179.5 divided by the base, which is 680. And that should give you the value of theta. Tan inverse of this, that's giving me 14.79. You can say that's 14.8 degrees. That is what we were looking for. The angle of elevation of the helicopter from the point C. Okay, that's your final result. Okay, let's have a look at one last question before we end. So now it says ABCDE is the cross section of a building. All the lengths are given in meters. Calculate DC. Okay, so this is the length that we want to calculate, DC. Now, do we have any triangle that we can use to find the length DC? If we make this triangle, for instance, we only have one length. If we make this triangle, we still have only one length, 6. So what do? What we can do is we can actually make a parallel line to the line DC here like this. Let's call this point something. Let's say this is point X. Now XB, this line is going to be the same distance, the same length as the length DC. Both of these are going to be same lengths. So if we can find XB somehow, that will be the same as DC. How can we find XB? Let's think about that. It's a right angle triangle. If this length is 6, this whole length, and on the other side, you can see this length is 4. What does that tell us about this small length EX? That's going to be 2 units. Okay. Now, using these two sides, what we can do is we can find the length XB, and that's going to be the same as the length DC. So let's find XB first of all. Using Pythagoras, we can say XB squared plus 2 squared, that equals 15.1 squared. And that can give us the value of XB. Let's see what that turns out to be. 15.1 squared minus 2 squared, square root of that, that's giving me 14.97. Okay, to 3 significant figures, you could say that's 15.0. Now, XB is the same as DC. So DC is also the same. We say this is also equal to DC. Now, we could write our final result correct to 3 significant figures if we want. You can leave it like this as well, and that's perfectly okay. Or if you want to round it off, that will be 15.0. That's the final result that you get. Okay. All right. Let's have a look at the next one. Next part. It says calculate the angle EAB. EAB. Okay, so that's pretty straightforward now. Simple application of cosine rule. This is the angle theta that we're looking for. We have all the other 3 sides. We can use cosine rule for this. Right? We don't have any other angle, so sine rule is not going to work. We can use cosine rule. Again, we could use the one with cos as the subject, the form that has cos as the subject. That gives us b squared plus c squared minus a squared divided by 2bc. Let's just input values in this. 15.1 is going to be A, the side opposite of theta. Others are going to be B and C. So we have 9 squared plus 11 squared minus 15.1 squared divided by 2 into 9 into 11. That is cos of theta. And that's going to give us the value of theta. Let's do this. 9 squared plus 11 squared minus 15.1 squared divided by 2 into 9 into 11. And then cos inverse. Oh, so there's something wrong with that. Just redo that. 9 squared plus 11 squared minus 15.1 squared divided by 18 and 11. And then cos inverse of that. That gives us 97.548. If you were to round it off, it would be 97.5 degrees. That's the angle EAB that we were looking for. All right, it's 97.5 for it. Now it says calculate the area of the cross section. So we have to calculate the area of this diagram. Right, this whole thing is the cross section of a building, A, B, C, D, E. We need to find the area of this whole diagram. How can we do that? We could divide it into two parts like this. We could say we have a trapezium. This one, we know the formula for area for trapezium, and the other could be this triangle. Right? We could use these two diagrams. Let me write that down here. So area of the cross section could be the area of the trapezium, which is BCDE, trapezium BCDE. Add to that the area of the triangle ABE. Now, what's that? Half into sum of parallel sides. What are the parallel sides? 4 and 6. Into height. Height is the distance between the perpendicular sides. What's that? We found that in the first part. It was 14.97. And from the first part, we know that this is 14.97. Let's use that. This is the area of the trapezium. Add to this the area of the triangle. What's the area of the triangle? It's half into base into height, but it's not a right angle triangle, so it's going to be difficult to find the height. We can use half into AB sine C. We have two sides and the angle between them. We can use AB sine theta, AB sine C, however you've done that. Half into 9 into 11 into sine of theta. Okay. So half into 9 into 11 into sine of the angle. Angle we found in the previous part was 97.55. Now you can evaluate this. That's going to give you the total area. 10 divided by 2 multiplied by 14.97. That's giving me 74.85 plus 9 into 11 divided by 2 into sine of 97.55. And that turns out to be 49.07. The total area is 123.9. That is the area of this cross section that we would. Okay. All right. Now it says a model of the building is made using the scale 1 to 50. What's the area of the cross section of the model? Give your answer in square centimeters. Okay. So the model is made using this scale 1 to 50. Original unit is meters. What's the area in meters? The area in meters is 123.9. 123.9 meters squared. Now the scale for the building and model, if the model is 1 meter, the building is 50 meter. right? That's what the scale represents. Now we're talking about area. Area is in meters squared. What that means is, if the area of the model is 1 meter squared, the area of the building is 50 squared, which is 2,500 meters squared. Okay. So if the area of the building is 123.9, what's the area of the model? 123.9 divided by 2,500. You can use ratios here. You can say if 1 meter square corresponds to 2,500 meters squared, what is 123.9 meters squared going to correspond to? What's this value going to be, right? So we can use ratios using these values in meters squared. First of all, let's see what that gives us. So we can cross multiply, right? Like, or we can make a fraction like this. 1 over x equals 2,500 divided by 123.9. And that gives us 123.9 into 1 equals 2,500 into x. The area of the model turns out to be 123.9 divided by 2,500. You can do it directly as well. That's giving me 0.04956 meters squared. Now we need to give our answer in centimeters square. 1 meter square. 1 meter is 100 centimeters. What about 1 meter square? That's 100 into 100, 10,000 centimeters square. We just multiply this by 10,000 and see what that gives us. Multiplied by 100 squared, you can say. And that's giving me 495.6 centimeters squared. That is what we were looking for here. 495.6 centimeters. If you wanted to round it off, you could say 496 centimeters squared, and that will be your final result. All right. That would be the area of the building in this case. And that's it. So I hope that was helpful. We've done quite a few questions, quite a few relatively more difficult questions on trigonometry from the last few years. Now, in the next session, we will be doing another topic, maybe mensuration or transformations. I also have a yearly past paper starting in a week or so. The registration link for that is there in the chat box here and the live chat. It's also there in the description of this video below. You can have a look at that. We will be covering yearly past papers for IGCSE maths, O-level maths, also add maths. We'll have separate sessions for each of them, starting from around 6th or 7th April. Okay, so you can have a look at the details at the registration link in the description below. I'll see you again in the next live stream on another topic. Allah Hafiz.